I'm just going to talk about the basic building block, that is DC block, for making this DC block so far. So I was fortunate to work with one of the guy in this picture who worked enormously in 1980s. And in 2019, they got the Nobel Prize. Good enough is now no more, but at the age of 97, he won the Nobel Prize. And whatever these guys develop, the theory, application, and fundamental that we are using in various application in the battery world. So typically cylindrical prismatic pouch. In the BESS is concerned, people work on the cylindrical and pouch in the European as well as in the US continent, but now prismatic LFP is commonly used. So in battery, there are various chemistries starting from lead acid people used in storage earlier to nickel cadmium and polymer batteries and nickel metal hydride. But now it came to lithium phosphate, and if the further development for then it is with the sodium ion and other thing. So in the overall, the BESS system, one of the important part that I'm talking is battery pack, which includes the cooling system, as Mr. Sharmaji has mentioned, about the challenges with the energy consumption. So hold the system in say 20 feet container. Earlier we used to get 2 megawatt hour, 3.5, then evolution started. Now still people are struggling to have 5 megawatt hour energy box, where internal cooling, HVAC system in the container, as well as battery pack cooling system where water glycol flows. Then we have to maintain the thermal management, different sensors, charging, safety aspect, and one important part is BMS, battery management system. It's like a brain which communicate in different layers to the EMS of the system. If we consider this, okay, battery requirement will. So just to give you more insight, like how it works, like in a battery bill, we have the different voltage, current, power, energy, then fault tolerance, redundancy, state of health, electrical interface, then mechanical, physical dimension, thermal performance, environmental constraints, then the safety. All parameters form the battery pack. Just give you an idea how the battery pack looks. This is just the schematic view, where what is inside the battery pack. There are different types of cells form the modules. Then different modules form the single battery pack. And in the 5 megawatt hour container, there are different modules from the racks and racks from the container. So inside the battery pack, there are these modules with the voltage sensor, temperature sensors. So these are the modules you can see. Then there is a thermal management system. These are the cold plates with coolant port, and then battery management system, this battery disconnect unit, pre-charge components, wiring harness, and so on. So overall, there are more than 100 plus components in battery pack system, which gives you energy with more than 52 to 104 kilowatt hour nowadays, with more than 300 volt system like that. So typically, this is always the battery consists of series parallel configuration. How you arrange its prismatic cells is very, very important. Then in the given dimensions, you can fit these battery packs. There are different challenges in terms of the design. Supply chain is one of the major challenge where we have the dependency on our neighboring country. Then manufacturing flexibility, quality standards, and so on. And other aspects that we are talking is thermal management system. Why it is important? We are talking about the high energy system. So at different temperature, different condition, inside the battery, there is an electrolyte, then electrodes, which leads to a capacity fading, then increase in the impedance rise, which gives the internal imbalance, then loss of mechanical stability, and so on. To avoid that, you can work with the different simulation software along with the different testing results in your lab, where you can test each and every cell before putting in the pack for testing validation and so on. Just to give you an example of severity of how it happened, there is one case in one part in Europe where 2.5 megawatt hour, one container catch fire, and it was burning for 5 days. There are various reasons. Cheap quality cell because it is cheaper to mitigate the tenders and so on. So cell imbalance, if in a one batch, there are say more than 5,000 cells, if cell is imbalancing, they will decrease the loss in the capacity, which leads to a control limits that you put on the BMS. So this, to avoid that, while selecting the cell is the very, very important. You can't just get the cell because it is cheaper and all. There should be a thermally or electrically stable also. Another important part is certification, where you have UL 1973 standard 9540, 9540A, 62619 on different application. IEC, UL and IEC both are the certificates required for this container. At the moment, none of the certification is possible. UL, complete container certification, is not possible in India. It's evolving at the moment. Then software evolution, functional safety standards, and so on. Once you make the pack and then container, you have to go through all this certification. So UL 9540A and so on energy storage system, then on inverter, converter, and so on. So container level, you need 9540. This is basically a test procedure in case of fire incident. Then rack level, there are different standards, UL 1973, 1743, and so on, and pack level also. Without this certification, you can't put your container in the field. So it is very, very important. So in JSW, we are doing the energy storage as well as various projects. The JSW Group, they are one of the #1 player in steel. Then we have infrastructure, paints, sports, different ventures, cement, and foundation. So as a new energy growth platform, I'm taking care of battery cell manufacturing as well as for the BESS, where we are also doing various ventures. You might see electric vehicle manufacturing, solar module, green steel, then green hydrogen also. These are the different initiatives we do in JSW. So thank you for your time.